Okay, AP Calculus, we're asked to prove that the first derivative of tan of x is actually equal to secant squared of x. I'm going to do it using the limit process. And the first thing I want to talk about is this little rule here that sine of x over x is equal to what? 1. Is equal to 1. Good, so this is x down here. So we're saying sine of theta, sine of anything over itself is 1. So I'm going to start doing this. The reason I'm showing you this is because I want to explain to you why I'm making this first move the way I am. And the first move I want to make is this one. I want to trade this in and take this as, right, tan is sine over cosine. So I'm going to take sine of x plus change in x over cosine x plus change in x minus tan here. So it's going to be sine of x, right, cosine x here all over change in x. And if it looks like it's more complicated now, it's going to get better in just a second. So change of x. Remember that we're in this limit process thing. So here, what I'm trying to get to is a complex fraction. So I have to put these two fractions together, Billy. So if you don't mind, I think what I'm going to do is this. I'm going to multiply this side by cosine of, yeah, x plus change in x over, nicely said, so x, change in x here, right? I took this denominator over here, didn't I? And used it here, and so I'm going to use this one over here, so I'm going to multiply this one by cosine x over cosine x, right? So look at this for a second, because this is where, if you know your trig identities, this will really, really help. And this is the subtraction formula for sine, isn't it? So when we multiply this, we're going to get this. We're going to get sine of x plus change in x. That's change in x. Times cosine x minus sine x, and you're going, well, how's that helpful? It's really helpful. Just hold on a second. X plus change in x, right? All over cosine x plus change in x. If you're still with me, you're doing great. Over change of x over 1. Right? Remember, we're in that limit process thing. So far, so good? Okay. I think that this is actually going really well. Okay, so this is where we have to stop for a second, because it looks like it got worse, but it got a lot better, didn't it? Because we know that there's this subtraction formula, and the subtraction formula tells us this. The subtraction formula says that sine of u minus v, we're going to do this reflexively, we're going to take this rule backwards, u minus v is equal to, yeah, exactly, sine u cosine v minus cosine u sine v. That is first and second, right? Isn't that what we have? Sine u cosine of the second minus, this minus sign is this one, sine of the second, that's this one, cosine of the first, that's this one, isn't it? It worked out perfectly, right? So what we can do from there is we can substitute this back and say, okay, what we really have is, remember you're in calculus, so even though we're doing trig in calculus, so you have to keep this limit process notation going. But you're going to take this as sine of u, well, what's u? X plus change in x, right? So u is x plus change in x minus v, right? So we're minus v, so v is just x, isn't it? Because those are the two numbers that we got, all over cosine x plus change in x. And if you don't mind, this is a complex fraction now, so I'm going to bring this up as its reciprocal. Is that okay? So I'll multiply it by 1 over change in x. So that change in x ends up here, doesn't it? Do a little simplifying here. X minus x, 0. So now look what we have. See if you can figure out why I did it this way. I'm going to take this limit again. Limit as the change of x approaches 0 of sine of what? Just change of x. I know how weird that is, but change of x over change of x times 1, right? Because this whole thing is times 1, isn't it? Times 1 over cosine x plus change in x. But what do we know about this value? Equals 1, and it's times this thing. Remember, our goal here was to let change of x equal 0. What would happen if change of x was 0 here? Would it be undefined? No, it would make perfect sense. We'd have cosine x times cosine x, which is what? 1 over cosine squared x. And by definition, 1 over cosine squared x is secant squared x. This squared is that one, isn't it? So we proved it. Good enough? I know, really. Somebody said yay. It was Barron's. You know how he is. Seriously.